this module, you will learn about linear inequalities in one variable. Consider the statement: if 5 is added to a number, it gives a number that is more than 10. This sentence can be expressed as x plus 5 greater than 10, where x is any number. Two real numbers or two algebraic expressions related by the symbols less than, greater than, less than or equal to, or greater than or equal to form an inequality. Shown here is a linear inequality in one variable. Here the term one variable represents the variable x in the inequality. There exist different types of inequalities, such as numerical inequalities, literal inequalities, strict inequalities, slack inequalities, linear inequality in one variable, linear inequality in two variables, etc. We will now learn about algebraic solutions of inequalities in one variable. Consider the given inequality. Let's start substituting different values in place of x on the left-hand side of the inequality, starting with 0. We get the value of the left-hand side as 3, which is less than 12. Next, we keep on substituting the subsequent values. We observe that when we substitute 5, we get the value on the left-hand side as 13, which is not less than 12. In the inequality, when we substituted the values of x from 0 through 4, we got the value on the left-hand side less than the value on the right-hand side. For all these values of x, the statement of inequality holds true. When 5 is substituted in place of x, we get the value of the left-hand side as 13, which is greater than the value on the right-hand side, which is 12. We can say that the statement does not hold true for x is equal to 5. Further, we can observe that the statement holds true even for the values of x less than 0. The solution set for the inequality is shown here. We observe that the solution set consists of integers. We may consider other solution sets based on the requirement. For the same inequality, the solution sets of natural numbers and real numbers is shown here. Therefore, the values of x for which the statement holds true are called the solutions of the inequality. Thus, any solution of an inequality in one variable is a value of the variable that makes it a true statement. The way the solutions were found for this inequality was by trial and error. We will use some rules that can be used in finding the solutions of an inequality. Equal numbers may be added to or subtracted from both the sides of an inequality without affecting the sign of inequality. Let's see an example. Let's subtract 3 from both the sides. Now, the nature of the inequality does not change. This applies for addition also. Both the sides of an inequality can be multiplied or divided by the same positive number without affecting the sign of inequality. Consider the example shown here. The value of this inequality does not change if we multiply it with a number. Similarly, the nature of the inequality does not change by dividing the inequality on both the sides. It has to be noted that when the inequality is multiplied or divided by a negative number, the sign of inequality is reversed. Let's consider the example shown. Let's multiply both the sides of the inequality by -1. Similarly, the sign of the inequality changes when divided by a negative number on both the sides. The intuition can be understood with the help of the real line. We know that 2 is less than 3. Let's multiply with -1 on both sides. We change the signs since we are multiplying with a negative number. If we observe the numbers on the real line, -3 is less than -2. That is why we change signs when we multiply with a negative number. Let's see how these rules can be helpful in finding solutions of inequalities. We will solve the inequality shown here. We will find the solution set. While we solve an inequality, the general technique is that we make the coefficient of x 1. For this, we take all the constants to the other side of the inequality sign. We will use the rules we discussed earlier to get the desired result. Let's see the procedure. First, we subtract 4 from both the sides. We get 3x less than 18. Next, we divide both the sides by 3. This way, we make the coefficient of x as 1. Therefore, we get the solution as shown. The solution set of this inequality consists of all the real numbers less than 6. Now, we will see how an inequality is represented graphically. Since the solution set belongs to real numbers, we take the real line. The solution set contains numbers less than 6. So we mark points left to the number 6, but not 6. The solution set of natural numbers for this inequality is shown here. Next, we solve an inequality having two algebraic expressions. As discussed earlier, the technique is to make the coefficient of x equal to 1. We will subtract 7 on both sides to bring the constant to the right-hand side. Next, we will take the variable on the RHS to the LHS to combine the variables. To do this, we subtract 3x from both the sides. We get 3x is greater than or equal to -15. Next, to make the x coefficient 1, we divide both the sides of the inequality by 3. We get the solution as x greater than or equal to -5. The solution set of the inequality is as shown. The graphical representation of the solution is as shown. Here the solution includes the number -5.